So let's say we have to delete an element from a singly linked list. So someone tells you that search for a particular element, and wherever that element is there in the list, remove that element. So let's say someone tells you that just search for 6, and wherever 6 is there, just delete that particular node. So in this case 6 is here, so we'll have to delete this particular node. Or let's say someone asks for 4, so if we have 4 here and we have to delete this particular node, or for that matter we have to delete 8, this is node. So the scenario is that this is the first node, this is somewhere in the mid or in between two nodes, and this is at the end. So given a particular number, according to that where the node is lying, we have to do the deletions. So we have seen that in case of insertion we had to do a different set of operations for end, in between the nodes, and first. So here we have to do different set of operation for first, but deleting in between the nodes or at the end have pretty much similar operation. We will see that how. So let's first go on to see that we have to delete, let's say 4 from the list. Someone tells me that let's say you have to find 4 and you have to just delete it from the list. So let's see how are we going to do that. So we have to, let's say, delete first node from a list, or I'll say someone asks you that delete 4 from the list, or delete a node which is having element 4. So for deleting the first node, we know that the first node is always pointed to by the head. For deleting this, we will see that how we are going to know that where is 4. But for deleting first node, let's say I know that 4 is the first node. For deleting 4, what we have to do is we have to update our head to point to the next element, which is 5. So we have to delete this particular node from the list, right? So obviously this is no more going to be my head. So the head has to be updated to the new first node of the list, which is this particular one. Now the question is, I have updated my head. What happens to this particular node? So if you would have coded in C, what we used to do, we used to write code for freeing up the memory occupied by this particular node. But here, in case of Java, automatic garbage collection happens if there is no reference to this particular object. So initially we had head which was pointing to this particular object. Now there is no one else who is pointing to this particular object. It's just lying somewhere in the memory without any reference. So when the garbage collection happens, this area of memory is automatically cleaned up. Okay, so in order to delete first node from the list, we have to do a simple operation. We just have to update our head to head dot next. Now this is simple, we just have to update our head, but here we are assuming that 4 is going to be the first element. How do we get to know that the node that we are deleting is the first element of the list? So for that, let's say I am keeping temp node for keeping track that where is the node lying. So where is this node with data as 4 is lying. So what I will do is I'll just use temp node to traverse through the array to just keep track of the node, that this is the node where the data is 4 or 5. So this temp node will keep track of that. So I will just start that while temp node dot data is not equal to num. Let's say this is num. We will simply keep on doing temp node equal to temp node dot next. Okay, so now what happens in case, let's say the number is not 4, let's say it's 6. So the temp node will start searching. So it will come here, it will see that okay, this is not the number, this is not the number. Now here, since this is the number, this loop becomes false, and temp node will start pointing this place. Now what happens if 4 is the required number? In that case, temp node will check that whether the data at this particular node is equivalent to num or not. So it is not equal to num, right? So this condition becomes false. The temp node keeps pointing to this particular node only. So if after this particular operation also, if our temp node is equivalent to head, then we know that okay, this, which means that the data that we're looking for or the node we are looking to delete is the first node itself. Then we apply this sort of operation. But we have few things to take care here. So let's say the list is empty. What happens in that case? So in that case, our head is null. So obviously the temp node, how do we make temp node point to this particular node? We do it using temp node is equivalent to head, right? So we do it temp node equal to head. So if our list is empty, then head becomes null, even the temp node becomes null. So when we do this particular operation, we obviously get the null pointer exception. We have seen this in the previous slides also, that we get exception here. So we have to keep a condition here that the temp node should not be equal to null and this particular condition. Now let's say that we put this condition that while temp node is not equivalent to null. So this loop will be false. We come here. So here what happens again? We are checking that temp node is equivalent to head or not. So since both of them are null, then this condition becomes true, which is something that I don't want. What happens that let's say after this particular operation, I start doing the operation of updating my head. So what we have to do is we have to again here put a condition that temp node should not be equal to null, right? And even if let's say I forget this, we have to put a condition here that if head is not equal to null. So we have to keep track of these conditions. So when we will write the complete code, we will see these things. So now let's go on to write the code for deleting first node from a single linked list. So we saw insertion till now, and the linked list we got till now was after insertion 1, 2, 4 and 3. Now let's say none. Now let's say someone asks you that you search for element 1, or for that matter search for a node having data as 1, and you delete this particular node. So let's see what we are going to do. So we will write a method for this particular thing. So let's say I call list.delete. So delete is the, so this 2 is the data that I want to delete. So here we are having just one method delete, and in this only we will write everything deleting from the end and at the middle or at the beginning. So let's first write for the beginning, and then as we see rest of them, we will update this particular method. Okay. So now let's say, let's have one more condition that we not only delete the number, we also print the number that is getting deleted, right? So here let's say I'm going to print what is getting deleted. Now let's say I have to delete the element. I void delete int num, right? So num is the data. So what we will do, the first thing that we have to do is we have to just find that where do the num exist in our list. So we will have a node, let's say temp node, which tracks the node that has to be deleted. So what happens is that we will search for this particular node. So we will do while temp node is not equal to null and temp node dot data is not equal to num. We just keep on updating our temp node, right? So now let's say I got my temp node. So I put a condition here that if temp node is equal to head, which means we are still at the very first element. So as we saw that this is one situation that we are at the very first element. Another situation could be that the list is empty. So if list is empty, we will just do if head is equivalent to null, then the list is empty. So we simply return from here. Or maybe, we can just print something that the list is empty. And then we return. So this is if the list is empty. Now let's say what if the list is not empty? So in this case, we will update our head to point to the next node. So after we have done this, let's call the print list function again. We have written this print list function while we were discussing the insert thing. So now let's run our code. Let's see what do we get. Okay. So we have, let me remove So we have print list here. So after we have done 3 insertions, we had 1, 2 and 3. Now we have inserted 4. So now we have 1, 2, 3, 4 and 3 in our list. We did a mistake here. We have to pass 1 as the parameter. Okay, so let me run this code again. So now we run this code again. So we have 1, 2, 3. So we had this print list here. So we do 1, 2 and 3. Then we have print list here after inserting 4. So we had 1, 2, 4 and 3. And now we are deleting 1, and after deleting 1 we had this 2, 4 and 3. So let me just remove these two prints and see the output. So now initially our list was 1, 2, 4 and 3, and after we deleted this we got 2, 4 and 3. So let's just quickly dry run this code. So initially we had 1, 2, 4 and 3. So we have temp node initially pointing to this node. We have both head and temp node pointing to this. Now we will just run through the list to find 1. So we just go through this list to find 1. So we have initially temp node not equal to null, which is true. Temp node is not null. Temp node dot data not equal to num. So this is false. Temp node dot data is num here. So we come out of this. We just check that if temp node is equivalent to head, which is the case, both temp node and head are pointing to this particular node. So we check that is my list empty? With this, if head equal to null, which is not the case, list is not empty. So we simply update our head to point to this particular node, which is 2. So now our updated list is something like this: 2, 4 and 3. So this is how the list is updated, and this is how the deletion is done from the front of the list. So what is going to be the time complexity? So we are just updating list from here, right? We are just deleting node here. So the time complexity is going to be O of 1 in this case. And even the traversal will happen only for this particular node for deleting the first node. So the time complexity is going to be O of 1. Now let's go on to see that how do we delete elements from between the lists or at the end of the list. Now let's say I have to delete a node after any node from a list. So let's say I have to delete 6 here. So let's say I have to search that where is 6 and I have to delete 6. Now for deleting 6, let's see what are the operations that we have to do. For deleting 6, somehow we have to remove this from the list. So how do we remove this from the list? So what if the next of 5, rather than pointing to 6, if next of 5 starts pointing to 7, right? So if next of 5 starts pointing to 7, then this 6 will not have any reference in the list. There will be no one in this particular list which is pointing to 6. So here you might be wondering that 6 is pointing to 7. So 6 is pointing to 7, but for 6 to be in this particular list, there has to be someone in this particular list which is pointing to 6, which is not the case. This link is already broken. So for updating this particular list or to delete this particular node, whichever node is before the node that has to be deleted, whichever node which is there before this node will start pointing to the next node of this node. Okay, might be getting confusing. So let's say this is my prep and let's say this is my current node. Let's say this is my current node and this is my prep node. So current node is the node that has to be deleted. So for the current node to be deleted, the next of prep node should start pointing to the next of current node. Right? So prep node dot next. So the next of 5 starts pointing to current node dot next, which is the next of this is 7. So this looks again pretty easy. There is one more thing that we have to do here. So we have to keep track of two nodes, if you would have seen here, the prep node and the current node. So how do I get these two nodes with me? How do I get a variable pointing to this node and this node? So let's see this. So let's do the operation of searching 6 in this particular node. So let's say we have head pointing to the first node, and then we have this prep node. Let's say the prep node is null initially, and then we have a current node, let's say, which is pointing to head, let's say initially. So with this as the current node, let's say I write this cn for simplicity. Now we will start looking for the current node. So every time we have to update two nodes, because you never know, this might be the current node. So in that case, this should be a prev node. So after every iteration, we have to update prev and current both. So what we will do is, we will do while current node not equal to null and current node dot data not equal to num. So let's say this is num. In this case, I'll do two things. Number one, I will update my prev node with current node. First, I'll do this, and then I will update my current node to point to the next node. So let's see if this is going to give me the right thing. So let's say I have to search for 6. So initially prev node is null, current is here. So now what happens that we check if current node is null. That is not the case. This is true. Is the data equivalent to current node data? Is this data and this data equal? No. So now what happens? This prev node becomes current node. So now the prev node, so let's say I write this Pn, starts pointing here after this particular operation, and this Cn starts pointing to this particular node. Now we again do the same set of checking. So again this condition becomes true. So now again the Pn now starts pointing to this node and this Cn starts pointing to this particular node. Now I again do the checking that whether current node is not null, true, whether the data of current node is equivalent to num, which is true. So this particular, we come out of this particular loop. So now we have our prev node pointing to this particular node and current node pointing to this particular node. So after we have our prev node and current node, we can perform this operation that prev node dot next is equivalent to current node dot next. So now let's go on to write code for this, and we will obviously check for scenarios. What if that current node is this particular node? Then what happens in that particular case? So now let's say I have the list with me 1, 2, 3, 4. Let's say now. And let's say I have to delete 3 first. So let's write code for this. So we have this dot delete here. Now let's say I update 1 to 4. So right now my list looks something like this: 1, 2, 4 and 3. We have to, let's say, delete 4 from here. So what I'm doing here is I am calling the delete method and passing the parameter or the number that has to be deleted as 4. Now if we see the implementation of delete, till now we wrote code in delete for deleting the first element. What if the node that has to be deleted is head? Now we will write code for deleting this particular node. So what we are going to do, as we saw in this slide, here we have a temp node. Let's make it current node so that it's more obvious, because we are going to right now introduce prev node. So we have okay, so we have current node and we are going to introduce one more node, which is prev node. So the prev node is initially null. The prev node, as we have seen, is keeping track of the node before the node that has to be deleted. So here while we are searching, so at this particular, in this particular loop, we are searching for the node that has to be deleted. So we now also have to keep track of our prev node. So what we do is we add that prev node is equivalent to current node. So every time we are updating our prev node as well. So now we have our prev node, we have our current node. So here we are checking that if current node is equivalent to head, which means we have to delete the first element, then this happens. Else what happens is, so let's say if this is the case, I simply return from here. Okay, now let's write down the code if the node that has to be deleted is not the first node. In that case, what we will do is our prev node dot next will start pointing to the next of current node. So that is all we have to do to delete any node after the node. So delete any node from between the nodes. So now let's see that whatever code we wrote is right or wrong. Okay, we have seen in the slides that if 4 is this particular element, then the code that we have used deletes this element, which is a node after any particular node. Now let's say, is this code working when we have to delete the last element as well? So let's just call this particular method with 3 parameter. So if we run this, as you can see that 3 gets deleted. So this particular thing works for a node in between and the last node as well. So let's try to see that how things are working here. Just let's try run the code once. So initially when we have 1, 2, 4 and 3, let's say I have passed 4 to be deleted. So we check for current node and prev node. So initially current node points to this particular place and our prev node is null. Initially is, let's say, null. Now what happens? We start searching for the element that has to be deleted. So we check that whether current node is not equal to null, which is true, and whether the data of current node is not equal to num. Here num is equivalent to 4. Okay, so here this condition becomes true. We come inside, prev node becomes current node, so prev starts pointing to this, and current node becomes current node dot next. So current node starts pointing to this. Similarly, we run the loop again. Now my prev node starts pointing to this and current starts pointing to this. So as soon as we get this particular thing, we check here that whether current node dot data not equal to num, this becomes false and we come out of the loop. So our prev is pointing to this particular node. If we write it again, so our prev is pointing to this particular node and our current is pointing to this particular node. Now what we are doing is we are checking if current node is equivalent to head, which is not the case. So I simply do prev node dot next. So the next of this prev node will start pointing to the next of current node. So the next of prev node starts pointing to this. So now there is no one referring to this particular node. So this node goes out of the list. So this is our new node. This is our new list. Now what if we have to delete 3? So in that case our prev will be 2 and our current will be 3. So what we will do is we will do prev is equal to current node dot next, and the next of this node is null. So now the next of prev starts pointing to null. So this is how the code will go. So this particular code works with both the cases. So this is the complete code for deleting. So whether the node that we have to delete is at the beginning, in somewhere in between, or at the end, it works in all the cases. So that was about deleting the nodes.